So in this video we're going to review the technique of indirect proof. So again, in topic 1 we looked at truth tables, and in particular we looked at the truth table for P implies Q, and then we looked at the truth table for not Q implies not P. We looked at the truth table for both of these implications, and what we discovered when we looked at it was that they match in every row. And because the columns for the truth tables were identical for each P implies Q and not Q implies not P, we concluded that these two statements were logically equivalent. And so the technique of indirect proof in mathematics is the technique in which we, instead of trying to prove directly P implies Q, we prove the contrapositive. Not Q implies not P, and because the contrapositive is logically equivalent to the original implication, proving that not Q implies not P is true proves that P implies Q is true as well. So indirect proof in mathematics, step 1, we find the contrapositive. We then use direct proof to prove the contrapositive. In other words, we'll assume that in step 2, we assume not Q is true, and we show not P must be true whenever not Q is true. So here's the basic technique. So here we have a proposition. It says if 3n plus 2 is odd, then n is odd. And this is a proof that would be hard to prove directly. If we assume 3n plus 2 is odd, it would be hard to get from that. It would be more difficult to get from that n is odd. So we want to prove the contrapositive instead. So what we recognize is we have the implication P implies Q, where P is the statement 3n plus 2, which means, which we have the statement 3n plus 2 is odd, and we have the statement Q, which says n is odd. So not P would be the statement that 3n plus 2 is even, and not Q would be the statement that n is even. So the contrapositive of our implication here is if n is even, comma, then 3n plus 2 is even. And what we're going to do is directly prove this contrapositive statement by assuming n is even and showing that if n is even, 3n plus 2 must be even, which will prove our claim, our original claim that 3n plus 2 odd implies n is odd. So let me get this out of my way. Die. So again, start off by preparing the reader for your proof. So proof. And now we want to tell the reader that we're going to use an indirect proof so that they know that we're trying to prove the contrapositive. And the contrapositive says n is even implies 3n plus 2 is even. So we're going to start by assuming n is even because we're proving the contrapositive. So suppose n is even. Well, if n is even, what does n look like? Well, it needs to be a multiple of 2. So let's say that. Then n equals 2 times k, where k is just some integer. And that is the form that an even number would take. It follows, now we're going to do some math. It follows that, well, we want to show that if n is even, 3n plus 2 is even. So let's take 3n plus 2 and replace the n with the multiple of 2 form that we have from right here. So replace the n with the 2k, so we get 3 times 2k plus 2. Well, this equals 2 times, I'm going to factor this 2 out, 2 times 3k plus 1, which shows us that 3n plus 2 is a multiple of 2, which means that 3n plus 2 must be even, equals 2 times k sub 2, where k sub 2 is just the integer 3k plus 1. So if 3n plus 2 is an integer multiple of 2, then 3n plus 2 is even. This implies that 3n plus 2 is even, which is what we needed to show, as desired. Spelled that horribly. As desired. So proving the contrapositive, which is what we just did, proves the original implication. Therefore, if 3n plus 2 is odd, comma, then n is odd. And we're done with our proof.